welcome again. I am Abhishek Saxena, and today I am going to discuss two-stroke engine in Introduction to IC Engine and Electric Vehicle series. Two-stroke engine. A two-stroke engine accomplishes the entire combustion cycle in just two stroke or piston movements of the piston per revolution of crankshaft compared to four-stroke in a four-stroke engine. As we can see the figure below, it shows the various part of two-stroke engine, starting with cylinder head, spark plug, piston, transfer port, exhaust port, intake port, flywheel, crank, connecting rod, crankcase. So as far as concerned with the part of the two-stroke engine, so these are structure, cylinder, transfer port, inlet port, exhaust port, spark plug, connecting rod, crank and crankshaft, crankcase. Most of the parts are similar as in four-stroke, but the cycle are different. Now, the working of two-stroke engine. One cycle of two-stroke engine is completed in two stroke of a piston in one revolution of the crankshaft. It has only ports at the cylinder walls and has no valves. The two stroke of the engine are suction plus compression means first stroke, power and exhaust means second stroke. So the suction and the compression completed in first stroke and the power and the exhaust is completed in the second stroke. As we can see in the figure, the intake and compression is going on in the first stroke when the piston moves from downward to upward, that can be seen in the figure 1. Here, the piston is moving from downward to upward and the charge is induced in the crankcase. The charge above the cylinder head, above the piston head is being compressed by the piston. After the first stroke, the combustion begins. Due to this combustion, the piston start moving downward and the expansion and exhaust of the burned gases takes place. So the entire cycle of the two-stroke engine has been completed in two stroke. First stroke, intake plus compression stroke, and the second stroke, expansion plus exhaust stroke. Now, scavenging. There is a process of removing burnt gases from the cylinder called scavenging. So if we define the scavenging, that will be the exhaust gases are removed from the cylinder with the help of fresh compressed charge. This process of removing exhaust gases is called scavenging. The scavenging is a very important process for the two-stroke engine since we need to remove the burnt gases from the engine by forcing it out with the help of fresh charge. Now, the merits of two-stroke engine. The first advantage of two-stroke engine is simple design. Two-stroke engine have a simpler design with fewer moving parts compared to four-stroke engines. Second is lightweight. The two-stroke engine are lighter in weight. The simpler design also translates to a lighter weight engine. This is beneficial in application where weight is major concern, such as chainsaws, motorcycle, and some airplanes. High power to weight ratio. Due to a power stroke in every revolution and a lighter design, two-stroke engine can deliver high power relative to their weight. Next is less complex maintenance. The absence of dedicated oil system can potentially mean less complex maintenance compared to four-stroke engine. As far as demerits of two-stroke concern, it has a lower fuel efficiency. Scavenging in a two-stroke engine isn't perfect. and some fresh air fuel mixture can escape with the exhaust. This leads to wasted fuel and lower fuel efficiency compared to four-stroke. Next is higher emissions. Incomplete combustion due to scavenging issues and burning of oil for lubrication contributes to higher emission in the two-stroke engine. The next drawback is shorter lifespan. The use of pre-mixed oil for lubrication can lead to increased wear and tear on engine parts, resulting in generally shorter lifespan compared to four-stroke engine. The next demerit is noisier operation. The simpler design often means less sophisticated noise cancelling mechanism, leading to noisier operation compared to four-stroke engine. The next topic is difference between two-stroke and four-stroke engine. In two-stroke engine, the whole cycle is completed in two strokes of the piston. The cycle includes suction, compression, expansion, and exhaust. In four-stroke engine, the whole cycle is completed in four strokes of the piston. In two-stroke, horsepower output of a two-stroke engine is twice that of four-stroke, but in actual practice, it is 1.5 to 1.8 times. In four-stroke, horsepower output is less than the two-stroke engine. In two-stroke engine, high pressure and temperature at the starting of compression stroke, hence thermal stress on the combustion chamber wall. Here, in four-stroke case, lower pressure and temperature as compared to two strokes, hence less thermal stresses. In two-stroke, less volumetric efficiency and poor scavenging, hence they are less efficient. Four strokes has more volumetric efficiency and better scavenging, hence more efficient engines. The fuel consumption in two-stroke are more. The fuel consumption in four-stroke engine is less. For two-stroke engine, more headroom is required. For four-stroke engine, trunk piston requires less headroom. In two-stroke engine, torque produced is more regular, hence the flywheel is smaller. In case of four-stroke, torque produced is irregular and hence heavier flywheel required in comparison with a two-stroke engine, as the number of operating cycle in a two-stroke engine is twice that in a four-stroke engine. Two strokes are used in low-speed, high-power diesel main propulsion. Four-stroke are used in medium-speed power generation. In two-stroke, one power stroke takes place at every revolution of the crankshaft. In four-stroke, one power stroke takes place every two revolutions of the crankshaft. Camshaft to the crankshaft ratio in two-stroke engine is 1:1, while in case of four-stroke, it is 1:2. Two-stroke low-speed engine can burn fuel of cheaper quality because of the very long stroke, which adds more time to scavenging and exhaust process. Four-stroke engine faces trouble in burning cheaper low-quality fuel, so they need a high and a better quality fuel. Higher power to ratio higher power to weight ratio in case of two-stroke engine, while less power to weight ratio in case of four-stroke engine. Now, the difference between the petrol and diesel engine, or the difference between SI and CI engine. CI engine stands for diesel engine and SI engine stands for petrol engine. In case of CI, engine works on the diesel cycle. SI engine works on the Otto cycle. In case of CI, the fuel is mixed with air inside the cylinder. In case of SI, air and the fuel are mixed in a carburetor. In CI, ignition is achieved with the help of the hot compressed air, while in case of SI, fuel is ignited with an electric spark. CI has a high compression ratio and SI has a relatively low compression ratio. CI has a high power production, while the SI engines have relatively low amount of power are produced in petrol engine. These engine works with fuels that have low volatilities. SI engine works with high volatilities fuel. CI engine generally used in heavy vehicles such as trucks and buses, while petrol engine are used in light vehicles. CI engine has relatively low fuel consumption, while SI engine have high fuel consumption. CI engine have high initial and maintenance cost, and SI engines are relatively low initial and maintenance cost. So this is all for today. In next lecture, we will discuss the electric and hybrid vehicle. Thank you. These are the references for the content I have taken for this lecture. Thank you so much.